Hi, welcome to this demonstration of the carbon storm model for calculating the carbon footprint of an urban landscape. I'm going to walk you through a few of the features for using this model so that you could then determine a carbon footprint for whatever sort of landscape that you have that you're interested in. So the first thing to do will be from this login screen to enter your username as well as your password, and after that you can simply log in. The first screen that you'll see once you're inside the model is to give you options to model various types of landscapes. So as you'll see from this pull-down menu, this model has built into it 9 different landscape types. The majority of them relate to different types of stormwater practices that you might have, be it a gray stormwater infrastructure solution such as a sand filter or something of a little more green in flavor, green stormwater infrastructure. And we also have built in just landscaped areas, whether that's pavement or trees or turf or other sort of areas such as that. So to get started, you would simply select the type of landscape with which you want to deal. So I will select bioretention for this example. And if you like, you can give it a name that means something to you. And I will add that. At this point, you would then have the option to add additional landscape types. So if you had a bioretention area with a parking lot draining to it, you could add a parking lot area as well. For simplicity here, I'll just go ahead and work with the bioretention, but you can add multiple landscape types as you need. So the first step will be to edit the landscape type that you have just selected. So I'll click the edit button here. Once you are within this screen, you'll see that it's broken into 4 parts, and these deal with each of the different carbon life stages of any of these types of landscapes. So first we're going to deal with the design parameters, so we can calculate here the carbon that's embodied in the materials used to construct that landscape. The second part will be to describe the types of construction, equipment, and transportation distances, so we can calculate the carbon involved in constructing the practice. The maintenance will be the next phase of a carbon life cycle, so we'll have you input information related to maintaining that practice. And then finally, sequestration, which allows you to calculate the carbon that is sequestered in any of the vegetation included in that landscape practice. So for this, I will leave these input parameters as they are. This model includes I'll say built-in parameters, so you but if you had a specific design, you could enter in the dimensions of your practice, the type of sand or other material and its thickness, types of outlet structures, basically any of the basic building materials used to construct that practice. This maintenance period here refers to kind of the lifetime you expect that landscape to be in order, and then that's used in the maintenance life cycle calculations. I'll do the same with the construction or transportation distances. Again, we have some built-in values relating to the different types of materials and the types of vehicles that would typically be used to transport those materials, but you can specify distances associated with each of those, as well as the type of construction equipment that you might have used in constructing that practice. So for excavation, placing the outlet, etc. But as you see, we have drop-down menus, so again, you have some ability to select different types of equipment if you know. Otherwise, you can use the default values. The maintenance, we have typical maintenance activities associated with each of the landscape types, and you can include in there the number of times per year that maintenance activity is completed, as well, again, some travel distance. So we're incorporating here both the emissions by the equipment, but then also the carbon emitted by the vehicles and getting crews out to the site. Finally, for the sequestration part, you can specify the number of trees, shrubs, or other vegetation that you have present in your practice. So here, we've got a typical bioretention cell, which has primarily trees, some shrubs, and some mulch there. Once you've got it where you like, you click the Save Edits. And from here, now we have our bioretention system that we have edited or made values as best represents your system. Again, you can add additional landscape types, but for us, I will just simply look at the carbon footprint for that bioretention cell we just looked at. So to look at your carbon footprint, you simply click the Create a New Run button. And this brings you to a screen that shows you the calculated amount of carbon involved in each of those categories, so embodied in the materials, emitted through construction, maintenance, and then that would be sequestered in the system by the vegetation. And so you can see for the system, for example, that we specified there for our bioretention system, we've got a lot more carbon emissions than we do sequestered. And so if you were trying to optimize your carbon, you could then go back and adjust parameters, adjust the distances that you had to source materials, or look at a different practice. These results can be viewed as a bar chart or as a pie chart, just to show you again how you can, different ways of looking at that carbon footprint. So this was a basic rundown of how to use the CarbonStorm model. We thank you for watching the video, and if you have any questions, please contact the CarbonStorm model team. Thank you.